Hello, our users. In this video, I want to show you how to perform wild bootstrap using R. First, I want to say the wild bootstrap was developed for linear regression models with heteroskedastic errors, meaning when the equivariance assumption is not valid. And the wild bootstrap, what it does is it multiplies residuals by a certain number of random variables, especially when typically with mean 0 and variance 1. Okay. Um, you can probably generalize this to more broad regression models, but in linear regression model, you have the mathematical properties to guarantee the performance of the bootstrap estimates. Okay. All right, let me walk you through this example. First, let's set a random seed using today's date. Sample size 100. We get two predictors, x1, x2, and then three beta coefficient and the epsilon, the error term, and use this linear regression equation to generate the dependent variable y. Put everything into a data frame, and this is what it looks like, the first few rows. After that, we can fit a linear regression model, LM, y tiered x1 plus x2, data equal to data. And here's the summary of the linear regression model. So the next step, we want to extract fitted values and residuals, and also the design matrix. And then we're going to perform the wild bootstrap. First, we say we want to do 1,000 bootstrap replications. And then we create a matrix starting with the NAs, and it's B number of rows B and number of columns 3. So we're going to store the bootstrap estimate for the beta 0, beta 1, and beta 2 in this matrix. We can set another random seed. Now here is we're doing the resampling for B in 1 to capital B. And then we do the resampling here. And then we get a Y star, which is the resampled random variables. And then we add residual underscore hat times this random variable V added to the Y hat, and we get Y star. And then we fit a bootstrap model, the Y underscore star regressed on X1 and X2. And then we extract the bootstrap coefficient from this bootstrap model. Okay. And after that, we want to do inferences. Then we can extract the standard errors using the apply function on the boot underscore coefficient on columns using the SD function. And then we name the bootstrap SE. Here's the point estimates. Okay, then if you want to look at the confidence interval, so you can specify the alpha level. So here's the 0.5. And then we can use the quantile function and get the percentiles or quantiles at alpha divided by 2 or y minus alpha divided by 2, and assign the column names, row names, and print out the confidence intervals. So you can see actually the confidence limits are in the columns. For example, 95% confidence percentile confidence bootstrap interval for x1 is 1.33947. and to 2.005406. So this is a very quick example showing you how to do wild bootstrap for linear regression models when the equivariance assumption is not valid. Thank you.